So here's another example of work. Notice that what we have instead of a cylindrical tank is now we have a hemispherical tank. So in terms of the volume of a slice, I do want you to see that it changes because you don't have the same area every single time like we did in the last example. Now I'm going to do this problem just using slightly different bounds to show you that things can be done in different ways and still get you the same answer. So the way I'm going to do it here is I want you to think of the tank at height 0, okay, the top of the tank, of course, top, and we're going to pump the oil. So notice we're given oil with a density. Pump oil to a height of 6 feet. Now you could start this at 0 and go to 10 and then 16, and there would be ways to do that. Other things would have to change, but this is a way to do this problem, and you'll see that it works pretty well. So what we want to think about in this example is, again, that each of these slices, wherever that oil has a different area of the circular piece. And so if we were to take a slice of it, that's what you're seeing here, is this slice. And you want to think about the fact that this is a slice of the tank, just, you know, cut like this. So we still have the 0. The radius of this tank, you can see, is going to be 10 because we're told that. So that's what this is here. And then you'll recognize that that's also what this is here because it's the radius of the tank, which is from the center down to any side. So what we're going to do is we're going to make this distance here x. And then what's going to happen is that's going to tell us that this little piece right here, using the Pythagorean theorem, this side is going to be, you know, because x squared plus that side squared equals 10 squared. So using the Pythagorean theorem, that's going to give us 10 squared minus x squared. So that's just a Pythagorean theorem idea. So that is our little slice, and then we'll see how it kind of comes together here. So in terms of the radius, and when we're talking about the radius of the tank, of course, that's different than the radius of each little slice because each little slice is not, you know, from the center to the edge. So when we think about the radius of each little slice here, that is some value here. That is this distance, because again, it just depends on where you are in the tank. So that's going to be this y value there, which is the square root of 10 squared minus x squared, or the square root of 100 minus x squared. Okay, so now we're going to think of an area of a cross section of a slice. So area of a cross section. So again, as opposed to the cylinder, which had the same, it had a radius of 2 all the time, our slices don't always have radius 10. So for us, we'll write that in terms of x, just to show you. It's still a circle, it's still pi r squared, but for our case, the r is this distance right here, not the 10 because it's changing. So we take r, which we have right here, and we square it to just get 100 minus x squared. So notice the difference there is a variable there. So that's the area of the cross section. And just like we did before, we can think about the fact that when we multiply that by the idea of the height, then we would have the volume of each cross section. So let's now think about the idea that we're pumping, you know, the liquid to a height of 6 feet from the bottom of -10 there. So let's think of the weight of a slice. So remember, for these problems, you have to think density times volume, that's what weight is, density times volume. we were told that our density is the 50 pounds per cubic foot, feet cubed. And then our volume is what we were kind of just talking about there. We have the pi times 100 minus x squared, and then times the height of each little piece. So that will be our delta x. And our volume there is in the same thing, that idea of feet cubed. So we end up, and you can write this in a couple different ways here, but we end up with the 50 pi times 100 minus x squared times delta x. I don't have my integral yet. Okay, so that is the weight of each slice. And then we're basically just going to integrate it here. So you want to think about the height of this whole thing, as you can see, is we're going up to 6. Okay, so that's important here. So when we think of our distance here, whatever we call x, the distance that's left, we've done this multiple times, is just 6 minus x, because that's what we are at the top. We're at 6, so we have 6 minus x. Now if you're saying, yeah, but we're not starting at 0, understandable. So let me set up the integral now. We'll have the 50 pi integral sign. We have, work is force times distance, so we have our 100 minus x squared with the 50 pi. We also have our distance, which is going to be 6 minus x, and then we have our dx. So this is what we're integrating. So notice it's a little more complicated than our last couple examples because of the fact that the slice is not a constant size. In terms of the limits of integration, remember that is how filled the tank is. So if the tank is filled completely, which we're not told that it is, it says it is a tank and it is filled. So we're going to go from -10 to 0 because that is the limits on the tank being filled. And so now we have everything that we need. So in terms of integrating, what we will need to do, you may or may not have noticed, but we are going to need to multiply this out in order to integrate. We don't have the techniques needed to do it any other way. So we'll integrate, we'll have 600, so just multiplying it out, 600 minus 100x minus 6x squared, and then plus x cubed. And that is our, what we have in sight, dx. And so now I'm basically just ready to integrate it and then just evaluate it, and then we'll be done. So 50 pi, we'll integrate that with respect to x, so 600x minus 50x squared minus 2x cubed plus 1/4 x to the 4th, and that is being integrated from -10 to 0. So you'll notice that when you put in 0, you are actually going to get 0. So when we do 50 pi, when we put in 0, we're putting 0 in first. That's 0, and then you're going to have a minus what happens when you plug in -10. So a -600, a minus 5,000, a positive 2,000, and then a positive, what is that, 2,500. So all we need to do now is add that together and then multiply it by 50 pi, and we get 325,000 pi foot-pounds. Whew. And that is section 5.4.